Okay, let us discuss problem number 1.259. Again, this is an easy problem. Let me first make the diagram for this problem. Diagram is slightly complicated, but we'll make the side view and then we can understand easily. So we have a cylinder, something like this, and there is a bigger mass, so it is difficult to make. So let me try. And this has something like this, and then this goes this side. And there are some threads that is bound on this. So threads are bound over this. And there is a mast that is hanging by this, and let us call, people are calling it A. So Irodov is calling it A. And there are some threads are also here, and this is attached to the ceiling. This side also it is attached to the ceiling. Both are in the same horizontal plane, and there is some threads that is bound over this round thing. So now you can understand. So let us first make the diagram, and he is calling this as a B, and radius of this is 2r. So this has a radius that is equals to 2r, and radius for this is r. So radius for the bigger circular is 2r. This is A, this is called B. This is figure 1.65. Let me read the question. In the arrangement shown in figure 1.65, bit A possesses mass m. So this has a mass m. And the pulley has mass, pulley B possesses mass m, capital M. So this has this system, this plus this is basically one system. He is calling this a pulley. So this has mass capital M. Also known our moment of inertia is I. So this pulley has a moment of inertia I. And moment of inertia is also known. Radius of r and 2r, that is also known. The mass of the threads is negligible. Find the acceleration of bit A after the system is set free. So we have to find what is the acceleration by which A is going down. So let us say acceleration of A is A. Now let us try to visualize what will happen if you leave the system. So if you leave the system, this mass will go down. If this goes down, this will start rolling. So this will roll, and there is a tension T here, and there will be tension T here, because things are symmetrical. So I can say if this string has a tension T, this string also has a tension T. Because things are symmetrical, there is no reason that this will have a different tension and this will have a different tension. There is no reason that you can prefer this string, you cannot prefer this string. You can give more tension to this string. There is, everything is symmetrical. This is the middle. This is also in the middle. So I can say tension on this and tension on this is same. Now let us try to figure out. So this system will move, this goes down, so this will move. So this will start moving something like this. Are you getting? So if it starts moving something like this, this also start moving this way. Now see, if this is the axis, this is the axis of cylinder. Now let us find it out. What is the relationship between acceleration of this mass and angular acceleration of this. So what first I will do is, let us try to draw a top side view. If I am looking from this side, what I will see? I will see this object. Okay, so I am making the same diagram again. So if I am looking from this side, I will see this. So I will see a circle of radius r. Are you getting? I will see this circle of radius 2r. So I will just see this circle of radius 2r. Everybody getting or not? So if I am looking from this side, I will see this, and there is a tension thread that I will also look. So I will look at thread here. In the back there is again thread that will also look. So let us say so by dotted. It will be basically not shown. It will not. I cannot see this thread that is in the back. So I can say this T plus T. So there is a 2T tension that is acting up. Okay. Now this mass, this I will see. So this mass is M. This I also see. This mass I will also see. And the radius is R for this and radius is 2R for this. Everybody knows. And the mass of this is capital is M. And the moment of inertia is I. For this is M. This is going down with acceleration A. Are you getting? Now we have to find out. So let us say what will happen. So this goes down. So this system will roll. So this will roll something like this. So let us say rolling is alpha. So this is rolling with alpha acceleration. Are you getting? Now let us say if I want to find what is the relationship in alpha and A, what should I use? So what condition I should use? Let us take some time, try to find out what is the relation between alpha and A. So how we will find the condition between alpha and A? For this, what we are going to use? We will use this point. Let us call this point as a point C. So if you see point C, now what is the acceleration of point C you have? Let us say center of mass of this is also coming down with acceleration A2. So this is coming down. So center of mass of this is coming down by acceleration A2. So you see this point has a 2 acceleration due to center of mass, that is A2 downward. Now this is going up also, so alpha times R up. Are you getting? So this radius is R. So it has acceleration alpha times R up, and this A2 is down. Now this point, so this length of thread is fixed. This cannot go increase. So this means alpha A2 should be alpha R. So I have a relation A2 is equals to alpha R. Because this thread length cannot increase, cannot decrease. So I have to have A2 is equals to alpha R. Are you getting? Now let us try to find out relationship between A, A2 and alpha. Now if you see this point, if you see simply this mass, this point is moving with acceleration A, so this has a point acceleration A. But acceleration of this point can be also found using this. So cylinder is moving with this acceleration A2, so this point is also moving with acceleration A2. So cylinder is rolling with acceleration alpha, so this point is also going down alpha into 2R. So A is basically equals to A2 plus alpha into 2R. This is my equation 2. Now if I plug the value of A2 is equals to alpha R, so A is equals to alpha R plus 2 alpha R. This is A is equals to 3 alpha R. So this is my equation 1. This is the only important point we have in this question. Now everything is very easy afterward. Let us try to again understand. If this point is going with acceleration A, so this point, acceleration of this point that is on the disk or on the pulley, I can find using this So this point is going downward with A2, so acceleration of center of mass is A2, so acceleration of this point is also A2. This is rotating by alpha acceleration, so alpha into this distance, that is 2r, and again this due to alpha this will come down, so alpha into 2r plus A2, that's the total acceleration of this point. And this acceleration from this side, I can also think this point is also part of the thread, but thread is going down with acceleration A, so I can also write A is equals to A2 plus alpha into 2r. Now if you consider this point, this is going down with acceleration A2 and this is moving with alpha, so this point has acceleration A2 downward and alpha into r upward. This point has to has zero acceleration because this point is a fixed point, length of the string is not increasing. So, or you can say this is not sleeping. So this point, the thread is not sleeping. So thread is not sleeping. This means A2 is equals to alpha r. If I plug all these values, I will have this equation. Now things are very simple. I have to simply apply the equations now. Let us make the free body diagram. Here I have force mg. Let us say tension in this is T1, and here I have tension T1. So if I write equation for this, I can write mg minus T1 is equals to mass into acceleration. If I write equation for this is going down, so this from here you will have force capital mg, so I can show you the force here. You understand basically. So the force acting is mg, capital mg. So I can write equation of motion for this. The downward force is mg plus T1 minus 2T. Are you getting? So mg minus plus T1 minus 2T. This is equals to mass into acceleration. Acceleration is A2. And A2 is nothing but alpha times r. So this equation is, let us call this equation is 4. And A2 is nothing but alpha times r because I want in terms of alpha. So mg plus T1 minus 2T is equals to m alpha times r. This is my equation number 5. I can write another equation for torque. What is the torque acting? So T1 into r, 2r. So T1 into 2r, that will rotate in this way. Are you getting? And T2 into T2T into r, this will also rotate in this way. So plus 2T into r, this will also rotate in this way, is equals to I. So moment of inertia is given into alpha. Are you getting? So we have equation, this equation 6. I can modify equation this also by dividing 2r. So I can write T1 plus T is equals to I alpha by 2r. Now I have equation number 4, 5, 6. Now equation solving. So let us try to solve these three equations. So first equation I have mg minus T1 is equals to ma. So for what I have to solve? I have to find the acceleration of bit A. So I have to solve for A. And the second equation I have mg plus T1 minus 2T is equals to m alpha r. This is the second equation I have. And third equation I have T1 plus T is equals to I alpha by 2r. So I have three equations I have to solve for basically. Okay, let us see how many of you are not able to write the top one. So let us go fast. I have to solve for basically A. So what can I do? So if I try to see this one, I need 2T and I have T1 here. So what I should do? I have to eliminate alpha also. So and then I have to, so what can I do? Let us say I divide, so from here I plug the value of alpha. So equation 2, so this is, let us say A, this is my equation B, this is equation C. So from here I plug the value of alpha. So what we will have, mg plus T1 minus 2T is equals to mr, and what is the alpha? Alpha is 2r by I, T plus T1. So what I am doing, from here I am finding alpha and putting in this equation. So alpha is 2r by I t1 plus t. So this equation I will have. Still I have to solve for no need. Basically I will not get the a from here. Okay, so I have to put alpha is basically a is equals to 3r alpha. One equation we have, you see, a is equals to 3 alpha r. So I have to use that one. So let us leave this one. So no need to do this. So let us put alpha a is equals to 3 alpha r, or alpha r is equals to a by 3. So I can modify equation b. So let us say modify equation b. So mg plus t1 minus 2t is equals to m. Alpha r is a by 3. This we have already proved. Here also, so t plus t1, this is equals to I by 2r, and alpha r is equals to a by 3. So you see here alpha is alpha r is equals to a by 3. So alpha is equals to a by 3r. You getting? Alpha is equals to a by 3r. So I can put here a by 3r. Now we can solve. And the first equation we have mg minus t1 is equals to m. Now this is easy to solve. What can I do is, so this is t1, so 2t1, and then I have here 2t. So what I should do is, let us multiply this equation by 2. If I multiply this equation by 2, so I will have 2t1 plus t1 3t1, 2t goes out. So let us multiply this equation by 3. Are you getting? And then add. If you add, so 2t goes, 2t1 plus t1 3t1, 3t1 goes. So we will have mg plus 3mg is equals to, let us say a common, so capital M by 3 plus 2i, so 2 goes, I by r square, I by 3r square, I by 3r square plus 3m. Are you getting? So from here you can write a is basically equals to m plus 3m into z, this divided by m by 3 plus I by 3r square plus 3m. Are you getting or not? Let us try to see this one. I can basically, if I want, I can solve slightly in a better way. So if I multiply by 3, so I will have 3 m plus 3m z, and if I multiply by 3, so I will have m plus I by r square plus 9m. So this is the acceleration of the block A. Are you getting? So this is a pretty good problem basically we have. So let me check the answer. I think it's right. Yeah. So m plus 3m into 3. Now important point in this question we have, the only important point we have in this question is constraint relationship. How to find out the relationship between different acceleration, that is the important part we have in this question. That is very, very important. That is, what I want to say is, I am interested in what is the relationship. So let us say I have acceleration for this block is A. So this is coming down with acceleration A. This is coming down with acceleration a2, linear acceleration of the center of mass of this is a2, and angular acceleration of this object is alpha. So what is the relationship between a1, a2 and alpha? That is the one important point. To find out the acceleration relationship, I am using two conditions. First I am considering this point, and again I am considering this point. So this point, I can consider this point is a part of this thread as well as this is a part of this disc or whatever, the pulley. So this point will have same acceleration as that of the acceleration of this block. So this point will have acceleration of alpha r. This will go down because if rotate this way, so alpha r will come down. So alpha r plus a2, because acceleration of center of mass is a2. So total acceleration is a2 plus alpha r. And r is in this case 2r. So alpha into 2r. And now this point has acceleration a, so I will have equation a is equals to a2 plus 2 alpha r. Now the next equation I will get from here. This point is not sleeping, so this point I have a zero acceleration. So this center of mass is acceleration a2, so this point will have downward acceleration a2. So acceleration of this point is a2. This point will also have acceleration alpha r up, because this is the radius r. So this will have alpha r. So alpha r goes up. So this point is not sleeping. So total acceleration is a2 minus alpha r is equals to 0. So a2 is equals to alpha r. So this equation. Now for you illuminate, you use these two equations, so you will get a is equals to 3 alpha r. Now the things are very easy. Now we have to write simply the two equations. One is translational equation for block A, because block A is not rotating, it's simply translating. So I have to write one translational equation for block A. And block 2, that is the pulley, is moving down as well as rotating. So I have to write two equations. One is translational motion, that is coming vertical down with acceleration a2. So force external is equals to mass into a2. Another, I have to write rotational equation, that is the torque, total torque. 2t1 is this side and t1 into 2r is this side. So total torque is equals to I alpha. So I have to write two equations for pulley. One is translational, another is rotational. Translational equation is equals to force external is equals to mass into acceleration. Rotational equation will be torque is equals to I alpha. And then I solve for A or alpha. Now only thing is equation solving. There is no important part. So three important part we have. What is the relationship between A, A1 and R, alpha? The second important part we have how to write translational equation for block A, translational equation for pulley, and rotational equation for the pulley. And once you have written all these equations, you can always solve. You can also think, let us say how many unknown we will have. Initially, even without doing any step, you can think this is coming down with acceleration a, so I will have one unknown a. This is rotating with angular acceleration alpha, so this is another unknown. The center of mass, this will come with some acceleration a2. Now tension in this is, let us say t1, and the tension is this is t. So how many unknown we have? I have 5 unknowns, so I need 5 equations. So 3 equations I know. One translational I can write for this, one translational for I can write for this, one rotational I can write for this pulley. So 3 equations I know. 2 other equation, and that two equation will come only from constraint condition. So you see there are 2 constraint conditions. One is this point. So this point has same linear velocity. So linear velocity of this point, the tangential point, will same as this. So I have to find that first condition, linear velocity of this point is equals to velocity of this point, or linear acceleration of this point is equals to acceleration of this mass. This is first condition. Second condition, this point is just not sleeping, so the velocity or total acceleration of this point is 0. That is the 2 condition. There is a 2 constraint condition. So in this case, we have written 2 constraint condition and 3 equations of Newton's, and then we have solved. We will discuss the next problem.